dimensions going on. So look at the surface area formula there. It is 2LW plus 2LH plus 2WH. Let's talk about what's really going on. If we're finding surface area, we are finding the area of all the faces. So L times W is the area of the rectangle on the bottom. Why is the 2 there? Why is there a 2 in front of it? There's one on top. It's the exact same thing on the bottom and on the top, so they have the same area. So instead of adding it twice, it's the same thing. It's just doing 2 times that area. L times H is going to give you the area of this front face. Same thing. There's a face just like it in the back, so it's 2 times that. W times H is this face over here on the right side. The face in the back is exactly the same. So that's where we're coming from here. I would suggest on your pictures to label the numbers. So on example number 1 there, the 13, if we're kind of matching it up to the diagram, the 13 is an L, the 7 is technically the width, and 9 would be the H. I encourage you to do that because it makes it very easy at that point to just plug in the numbers into the equation. Now, the order technically doesn't matter, but you got to make sure that you don't repeat anything in the wrong place. So that's why I think it's best to just label those and follow the formula. Exactly. And then it's just a matter of plugging and chugging those numbers. 2 times 13 times 7 plus 2 times 13 times 9 plus 2 times 7 times 9. So we get the surface area is, what was that, 542? Yeah. Okay, surface area is 542. What are the units on area? Squared. Okay, area is always squared. The reason why it's squared is because all we've done is multiply 2 dimensions by each other. 13 times 7, that's feet times feet. The 2 doesn't have a unit, because the 2 is just representing that we have 2 faces. So we've got feet squared plus feet squared plus feet squared, and that equals feet squared. Okay, example number 2 there, kind of looks like it's slanted, but it really doesn't matter. It's still what we need it to be. So if we label this one, I'm going to say that 10 is the length. It kind of depends on which way you look at it. It keeps on flipping around when I'm looking at it. I see 16 as a height. You may see it as a length. You may see it as a width. It really doesn't matter. Just so you label those 3 dimensions with 3 different designations there, you're going to be fine. Okay? You just don't want to repeat any of those things. So the length is 10. The width is 5. The length is 10. The height is 16. The width is 5. The height is 16. And again, we're just crunching those numbers. 20 times 5 plus 20 times 16 plus 10 times 16. We get 580 for that surface area. Oops, these are centimeters, not feet. So square centimeters for that one. Okay, so rectangular prisms, or the same thing applies to a cube. Okay, except in a cube, your length, width, and height are all the same because all your dimensions are the same in a cube. Okay, any questions about rectangular prisms / cubes? Pretty straightforward. Okay, now we're going to lump all other prisms together. So let's look at the formula over there on the left-hand side. It says first find what we call the lateral area. That's the area of the non-bases. Then add the area of the bases. So look at the formula that they give us there. The lateral area is H times P. H is the height of your prism, what we're used to it being. P is the perimeter of the base. P is the perimeter of the base. On the surface area formula there, do me a favor and mark out the LP and just replace that with LA. They're equal to each other. I just think that it's easier. The way that I'm going to set these up I think it's more clear if you write it that way. So the surface area is equal to the lateral area plus 2 times a big B. Big B is always the area of the base. We talked about that with volume. We're using it here with surface area as well. So 2 times big B is still the area of the base. So that's what we're going to do. We're going to find the lateral area. We're going to find the area of the base. And then we're going to plug it into our formula there. So lateral area is equal to the height of the prism. On number 4, which one of those 4 dimensions is the height of the prism? 16. 16 is the height of the prism. So 16 times the perimeter of the base. The base is the triangle. The triangle is the base. Remember, the base of a prism is whatever has a parallel and congruent shape. So we've got a triangle here at the bottom and at the top. So we're going to find the perimeter of that triangle. One side is 9, one side is 12, the third side is 15. It's not labeled in the same place, but it is the third side of our triangle there. So our lateral area is 16 times 9 plus 12 plus 15. It's 576. Is our lateral area. Okay. Now, really what you've done is you have just found the area of those 3 rectangles, the 15 times 16, the 12 times 16, and the 9 times 16. You just did it in kind of a shorter, more condensed way. Now we need to find the area of the base. Our bases are triangles, so area of the base is 1/2 times, what would be the base of the triangle? 9, 12, or 15? Let me label them down here as well. If you had to say which one was the base of the triangle there, would it be the 9, 12, or the 15? 9 or 12, either one. Okay, remember the base and the height have to form a right angle. The 15 is the hypotenuse. It is not going to be the base, it's not going to be the height. So it really doesn't matter which one you look at as the base and the height, it's going to be 9 and 12. The 15 has nothing to do with the area of the triangle. It's the hypotenuse. So 1/2 times 12 is 6. 6 times 9 is 54. You are most certainly welcome to use your calculator. I'm just saving some time there. So now if we go to our surface area, okay, so we've found 2 separate areas, the lateral area, the area of all the non-bases, and then we found the area of the base. So the surface area takes our lateral area of 576 and adds 2 times the area of the base, because we have 2 of those triangles, right? So it's 2 times the area of the triangle. So 576 plus 2 times 54 is 684 square meters. Okay. Number 5. Number 5 is another triangular prism. Why do I know it's a triangular prism? Because I'm looking at a triangle right here and a triangle right there in the back. So it is a triangular prism. So the lateral area is the height of the prism. What's the height of the prism? 3, 5, 4.1. Height of the prism. Remember, the base has to be flat. This is not sitting on its base right now. It's got to be sitting so that the triangle is sitting flat. So we've got to tilt this forward towards us. So what would be the height? 3. 3 is the height of the prism. 4.1 is the height of your base. Okay, so 3 is the height of the prism. The perimeter of our base, the perimeter of the triangle, is 5 plus 12 plus 10. $81. The base is another triangle, so it's 1/2 times the base of the triangle is 12. The height of the